Hello, Luke. Welcome to Lesson 55. So today we're going to be talking about division of complex fractions. Should be pretty straightforward, so let's just start digging into it. The first thing we need to go over is complex fractions. What are they? And then we can talk about the division of them. So let's try it. What are complex fractions? Well, in your notebook, go ahead and write down this definition so that you have it for future study. Complex fractions are simply fractions that contain fractions within the numerator and or the denominator. All right? So they're just fractions inside fractions. They can look a little bit intimidating because they're pretty massive when you start looking at some bigger problems. But it's pretty straightforward. So here are a couple of examples. So in this first one, we see that the numerator is actually a fraction. It's 3/4. And then we also see that the denominator is a fraction. So we have 3/4 over 1/2. This would be a complex fraction because we have fractions within fractions. Okay? Fractions for the numerator, fractions for the denominator in this case. Another way to think about this is 3/4 divided by 1/2. All right? That's another way to read this. 3/4 divided by 1/2. And usually when we have complex fractions, the fraction bar that's separating the numerator from the denominator is usually going to be longer. So you can see that here. This fraction bar is just longer than the other two. That helps to just kind of keep things organized so we recognize where the numerator is and where the denominator is. All right. So in this next fraction here, it's another complex fraction because, again, we have a fraction in the numerator and a fraction in the denominator. It's that simple. This one is more complicated, but again, you can see that there is a fraction in the numerator and a fraction in the denominator. All right. Now, I could throw a couple more examples out here. What if I have x over a over b? This would also be a complex fraction. There is not a fraction in the numerator. It's just an x. But we do have a fraction in the denominator. So that still would constitute a complex fraction. All that's needed is either the numerator or the denominator has a fraction in it. All right, so this would be a complex fraction. This also would be, so if I have, well, let's go back to black. If I have a over b over c, this would also be a complex fraction. In this case, it's just the reverse of the last one. We have the numerator containing the fraction, and the denominator is just a single variable. All right, so that's the very basics. That is what a complex fraction is. It's, again, just a fraction within fractions. All right, so make sure you have this kind of written down in your notebook so that you can study this for later. And then the next question might be, how do we simplify complex fractions? And that's really the meat of the lesson for today. So let's try a couple examples. If I have something like 3/4 divided by or over 1/2. This is an example, obviously, of a complex fraction, and we want to try to simplify it. And the goal to simplify this is really to take this denominator, this fractional denominator, and somehow get that to be a 1. Because if we could somehow get that to be a 1, it would, in a sense, it would eliminate it. So if you think about it, if I have, 3/4 over a 1, well, that's just 3/4 divided by 1. And anything divided by 1 is going to be itself. So 3/4 divided by 1 is the same thing as 3/4. So in a way, if we can get this lower denominator to be a 1, and in a sense, it eliminates it. And we're just left with whatever's in the numerator. Right? Okay, so hopefully that makes sense. So that's kind of the overview. That's what we're trying to accomplish here. We're trying to get this denominator to equal a 1. So the question is, how can we do that? And you have to kind of dig back into what you've already learned here. Do you remember reciprocals or inversions? Do you remember if I have a fraction, any fraction, let's just make one up. Let's say I have the fraction 7/8. If I have the fraction 7/8, do you recall what happens when I multiply it by its inverse? So if I multiply this by the inverse, well, first of all, you need to remember what the inverse was. Remember, the inverse is just the flip-flop version. We just take the numerator and swap it out for the denominator, and likewise for the denominator. So the 7/8 becomes 8/7. And do you remember what happens when we multiply a fraction by its reciprocal? The answer is always going to be 1, right? So if we take a fraction, any fraction, multiply it by its reciprocal, the answer is always going to be 1. That is key. That is key. We learned that a long time ago, but just to refresh your memory, that is how the inverse works. So here, if our goal is to make this denominator into a 1, well, we have a tool to do that. And the tool is the inverse. So what's the inverse of 1/2? Well, the inverse of 1/2 is 2/1. So we're going to multiply this denominator by a 2/1. And if we do that, that's going to make this denominator equal to a 1, which is the goal. Now, we can't just multiply anything we want by anything we want and say, there, it's done. We have to follow the rules. And remember, with any fraction, so maybe again over here, if I have the fraction 3/4, I can multiply the denominator by any number that I want, so long as I multiply it by that same number in the numerator. So for example, if I want to take this 4 and multiply it by a 2, that's fine. I can do that so long as I also do it in the numerator, right? Because in a sense, what I'm doing here is I'm just multiplying it by 2/2. And 2/2 is 1. So I'm multiplying 3/4 by 1, which of course isn't going to change the value of 3/4. Okay? But it is going to change the numbers. So I have 3 times 2 now, which is 6, 4 times 2, which is 8, and 6/8 is equivalent to 3/4. They represent the same value. If I were to draw a pie, they would both represent this much pi, right? They would be equivalent. I mean, this I'd have to cut it into eighths, but essentially it would still be representing this much pi. So the amount of pi is the same, right? This is all review. This is just looking at equivalent fractions again. So 3/4 and 6/8 is equivalent. And we can do that by multiplying the numerator and the denominator by any number we want. We chose 2 in this case. We could have chosen any number, right? So that's just how equivalent fractions work. So over here, I do have a complex fraction, and I want to multiply that complex fraction in the denominator by a 2/1, which I can do legally so long as I multiply it in the numerator as well by 2/1. Okay? So this is the same process. Just like here, we multiplied the numerator and the denominator by 2. We're doing the same thing here. We're just multiplying it by a 2/1, which actually, interestingly enough, turns out to be a 2. But anyway, so we're multiplying it by the same thing in the denominator as in the numerator. All right. Now, if we do that, this is where it gets interesting. We have in the denominator, these are going to cross cancel, and we just end up with that 1. Which is perfect. That's what our goal was. In the numerator, we have a 3 times 2, which is a 6, and in the denominator, 4 times 1, which is 4. So we end up with 6/4/1, which is the equivalent to 6/4, which we could even reduce to 3/2. Okay, so this nasty little complex fraction, we can actually simplify by trying to get the the denominator equal to a 1. And we do that by making equivalent fractions, multiplying the denominator by its inverse, and then multiplying the numerator by that same inverse. Okay? All right, so let's just try another one. Hopefully it'll become more clear with practice here. If I have 7/8 divided by 3/4, okay, what am I going to do? Well, again, I'm trying to get this denominator to equal a 1. And what did we say the tool is that we will use? It's the inverse. So what's the inverse of 3/4? It's 4/3. Okay? So we have to multiply the denominator and the numerator by 4/3. We know that the denominator is then just going to cross out by design to be a 1. That's the intent. And then in the numerator, we have 7 times 4. Well, we can cross cancel here a little bit. The 4 can go into itself once, into 8 twice. So we end up with 7/6. And of course, this is just going to be 7/6. I could make this proper. We'll just leave it improper. All right. That is how we would divide these two fractions, 7/8 divided by 3/4. Okay. Now, I'm not sure how you did this in your pre-high school years, but in many mathematical books in grade school, you would have learned how to divide fractions. You would have learned that if you have something like 1/2 divided by 3/4, okay, you would have remembered that to do this, you first change this to 1/2 times, and then do you remember flip-flopping this, writing the inverse of this 3/4? You'd write the inverse as 4/3. You just flip-flop them, the division changes to multiplication, and you end up with 4/6, or 2/3. Okay, that is how you learned how to do this in grade school. This is the same process, it just looks different. All right, instead of writing this division sign in algebra, we like to use the fraction sign. So we would write this as 1/2 divided by 3/4. Okay, that's all we would do. That's just a different way of writing it. And then to solve it, we would then have to, in a sense, take this 1/2 and multiply it by the reciprocal of the denominator, which is or the inverse of the denominator, which is 4/3. Okay, and of course we're doing that in the denominator as well. These just eliminate and you get 1. So really the work of the problem takes place in the numerator. And we end up with this 1/2 times 4/3, which is exactly what we had here when we did this in grade school. Okay, so it's the same process. It's just there's a little more detail shown here, and we're using a different division symbol. All right? Excellent. So let's practice a couple of these and see how you do. So I'll do the first one with you, and then I want you to do the rest of them on a separate sheet of paper. We'll do them one at a time, and we'll see how you do. All right, so this first one, we have 1 over a divided by c over b. And we can take a shortcut here, and we don't really need to write out every time that we're going to take the c over b and multiply it by its reciprocal, b over c. All right, we can take a shortcut here and just know that that's what's going on kind of behind the scenes. And the shortcut is just going to be what's going on in the numerator. So we have the 1 over a, and we know that we're going to multiply that by, instead of divide, we're going to multiply that by the reciprocal of the denominator. So the reciprocal of c over b is going to be b over c. Okay, so again, all I'm doing is just multiplying the denominator by its reciprocal, same thing in the numerator. But knowing that this is just going to be a 1, we don't really need to do that every time. The part that really matters is what's going on in the numerator. So I'm just taking a shortcut and writing out the numerator and allowing myself to kind of just forget about the denominator because I know it's going to be a 1. Okay, so we have 1 over a times b over c. Now it's just simple multiplication. So we have 1 times b, which is a b, a times c, which is ac, and there we go. There's our solution. All right, so go ahead and try this next one right here, and then we'll do it together and see how you did. All right, so we have basically the same kind of problem here. And again, we're going to use the shortcut. We're just going to concern ourselves with the numerator. We have x squared over b. We're going to multiply that by the reciprocal of the denominator, which is x over b. Okay, and then we can multiply that out. We're going to have in the numerator x to the third, and in the denominator b squared. And that's our solution. It's just that simple. All right, try this one up here by yourself, and then we'll do it together. All right, so once again, the form is the same, the method is the same. We'll take the k over w, and we're going to multiply that by the reciprocal of the denominator. Now, the denominator here is a little bit nastier. It has a sum in it, but we still just take the reciprocal of that. So the denominator becomes the numerator, so that's going to be a w plus 1, and the numerator becomes the denominator, which is just a 1. All right, so you can see how this is just still the reciprocal. It's just there's a sum in there. Now we can multiply this out. This gets a little bit more dicey, and that's because we have this sum. Remember, sums are always going to make things a little bit more complicated. So if we have k times the sum, we have to remember that that sum should be written in parentheses because this k is being multiplied by everything in the numerator over here. Don't write this as k times w plus 1. All right, because there you're only multiplying the k times the w. And k is not being multiplied only by the w. It's being multiplied by the 1 as well. Everything over here. All right, so we have to make sure we put that in parentheses. K times the w plus 1 over w times 1, which is w. And we could leave it like this, or if we wanted to, we could distribute the k through and have a kw plus a k all over w. Either one of these would be correct. And unless there's something that could cross out, which you probably can't most of the time, this is probably the usual answer that you would write. But either one is fine. If you want to distribute through, you certainly can. All right, let's move on to the next one. Try this one by yourself, and then we'll do it together. All right, so again, method is the same. We have a c in the numerator, all right, which hopefully didn't throw you off. But we're going to try to write that as a fraction. So it'll be a c over a 1. Okay, that's what this numerator is c over 1, if we had to write it as a fraction. And we're going to multiply that by the reciprocal of the denominator, which is going to be b plus c over a. All right, and then we have to multiply the numerator out. We have a c times, don't forget the parentheses, b plus c, all over a. That would be our solution. And again, if we wanted to, we could distribute that through and get a bc plus c squared over a. That would be an acceptable answer as well. All right. Okay, let's try another one here. Here, it's similar to the last one, only here we only have a fraction in the numerator and just a regular number in the denominator. So try this one out and see how you do. All right, so once again, we have 1 over a is our numerator. Now we're going to multiply that by the reciprocal of the denominator. What's the reciprocal of a b? Well, if we have to write a b as a fraction, it would be b over 1, right? So if we take that and now find the reciprocal of that, kind of invert it, we have 1 over b. So that's what we'll use. And in the numerator then, we have 1 times 1, which is 1. And in the denominator, we have a times b, which is going to be ab. And that would be our solution. So if you don't see how I did that, especially on these last two, so this one and this one, if you don't see how those ones worked, make sure you kind of back up the video and just go over it again and just recognize how that c can be thought of as c over 1, and this b can be thought of as b over 1. All right? Very good. And that's about all we need to get through today. So maybe make sure this is all, taken care of in your notebooks, and then... Okay, well, that should be all we need to get to today. So make sure that you have this clearly set up and defined in your notebook, and then go ahead and start working on the seat work today. And I will see you tomorrow.